Understanding the licensing process for electricians, particularly the grandfathering clause, is important. Grandfathering allows individuals with a certain amount of experience to obtain a license without taking the standard examination. The intention is often to recognize the practical experience of those who have been working in the field for many years. There are advantages and disadvantages to this system. Firstly, it can provide a pathway for experienced workers to become licensed, ensuring that their skills and knowledge are recognized. Secondly, it can help to address labor shortages in the electrical industry by bringing more qualified individuals into the workforce. However, the main disadvantage is that it can potentially allow individuals with insufficient knowledge of electrical codes and safety practices to become licensed. This can pose a risk to public safety and undermine the credibility of the electrical profession. There are a few ways to address concerns about the competence of grandfathered electricians. One is to encourage continuous education and training. Even if an electrician has been working in the field for many years, it is important for them to stay up to date on the latest codes and standards. This can be achieved through continuing education courses, workshops, and online resources. Another way to address concerns is to promote mentorship. Experienced electricians can share their knowledge and skills with newer electricians, helping them to develop the necessary competence to perform their jobs safely and effectively. In addition, it is important for licensing boards to have clear and consistent standards for grandfathering. These standards should ensure that individuals who are grandfathered in have the necessary experience and knowledge to be competent electricians. This might involve requiring grandfathered electricians to pass a competency exam or complete a certain number of hours of training. Some specific areas that electricians need to be knowledgeable about include the National Electrical Code, or NEC. The NEC is a set of standards for safe electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. All electricians should be familiar with the NEC and follow its requirements when performing electrical work. Some examples of NEC requirements include those found in Article 210.8, which covers ground fault circuit interrupter protection for personnel. This section specifies where ground fault circuit interrupters, or GFCIs, are required to protect people from electrical shock. Another important section is 250.122, which deals with the size of equipment grounding conductors. This section specifies the minimum size of the grounding conductor that must be used to ground electrical equipment. Other vital articles and tables include 300.4 regarding protection against physical damage, 310.15 covering ampacity of conductors, which is how much current a conductor can safely carry, and tables like 310.16 and 310.17 which provide ampacity values for different types of conductors and insulation. Proper use of overcurrent protection devices like circuit breakers and fuses is governed by Article 240. These devices are designed to protect electrical circuits from overloads and short circuits. Installers must understand how to select the appropriate size of overcurrent protection device for a given circuit. Grounding and bonding are essential for electrical safety. Article 250 provides detailed requirements for grounding and bonding electrical systems to minimize the risk of electric shock and fire. Working spaces around electrical equipment must meet minimum clearance requirements as specified in 110.26. Sufficient space ensures that electricians can safely access and work on electrical equipment. Wiring methods such as conduit, cable, and raceways must be installed according to the requirements in Chapter 3 of the NEC. These requirements cover things like support, protection, and allowable uses. Voltage drop can affect the performance of electrical equipment. Informative Annex C provides guidance on calculating voltage drop in electrical circuits. Special occupancies such as hazardous locations, healthcare facilities, and places of assembly have additional requirements in Chapter 5 of the NEC. These requirements are designed to address the unique electrical safety challenges in these occupancies. Equipment listing and labeling are important for ensuring that electrical equipment meet safety standards. Article 110.3 requires that electrical equipment be listed and labeled by a recognized testing laboratory. Understanding the NEC involves knowing where to find information. The NEC is organized into chapters, articles, and sections. Use the index and table of contents to locate specific information. Many online resources are available to help electricians understand the NEC. These resources include websites, forums, and online training courses. Continuous education is essential for electricians to stay up to date on the latest changes to the NEC. Attend classes, workshops, and seminars to learn about new requirements and best practices. In addition to knowledge of the NEC, electricians also need to have a strong understanding of electrical theory. This includes concepts such as voltage, current, resistance, power, and magnetism. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Magnetism is a force that is created by the movement of electrical charges. It is used in many electrical devices, such as motors and transformers. Ohm's law is a fundamental law of electrical theory that relates voltage, current, and resistance. It states that voltage equals current times resistance, or volts equals amps times ohms. Power can be calculated using the formula power equals voltage times current, or watts equals volts times amps. Series circuits are circuits in which the components are connected in a single path. The current is the same through all of the components in a series circuit. Parallel circuits are circuits in which the components are connected in multiple paths. The voltage is the same across all of the components in a parallel circuit. Series parallel circuits are circuits that contain both series and parallel connections. Electricians also need to be familiar with a variety of electrical tools and equipment. These tools include voltmeters, ammeters, ohmmeters, wire strippers, pliers, screwdrivers, and conduit benders. A voltmeter is used to measure voltage. An ammeter is used to measure current. An ohmmeter is used to measure resistance. Wire strippers are used to remove the insulation from electrical wires. Pliers are used to grip and manipulate electrical wires and components. Screwdrivers are used to tighten and loosen screws. Conduit benders are used to bend electrical conduit. Electricians need to be able to use these tools safely and effectively. They also need to be able to troubleshoot electrical problems. Troubleshooting involves identifying the cause of an electrical problem and then taking steps to fix it. This requires a strong understanding of electrical theory and a good deal of experience. Some common electrical problems include short circuits, open circuits, ground faults, and overloads. A short circuit is a low resistance connection between 2 points in a circuit that are at different voltages. This can cause a large amount of current to flow, which can damage equipment and start fires. An open circuit is a break in a circuit that prevents current from flowing. A ground fault is a connection between a live conductor and ground. This can create a shock hazard. An overload is a condition in which a circuit is carrying more current than it is designed to carry. This can cause the wires to overheat and melt, which can start a fire. To troubleshoot electrical problems, electricians use a variety of techniques, such as visual inspection, voltage testing, continuity testing, and resistance testing. Visual inspection involves looking for obvious signs of damage, such as burnt wires or loose connections. Voltage testing involves using a voltmeter to measure the voltage at various points in a circuit. Continuity testing involves using an ohmmeter to check for continuity between 2 points in a circuit. Resistance testing involves using an ohmmeter to measure the resistance of a component. Electricians must follow safe work practices at all times. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and hearing protection. It also includes using lockout-tagout procedures to de-energize electrical equipment before working on it. Lockout-tagout procedures involve disconnecting the power to electrical equipment and then attaching a lock and tag to the disconnect switch to prevent it from being accidentally turned on. Working on live electrical equipment can be extremely dangerous and should only be done by qualified personnel who have received specialized training. Electrical safety is paramount. When working on or near electrical equipment, always assume it is live until proven otherwise. Use appropriate personal protective equipment, including insulated gloves, safety glasses, and appropriate clothing. To energize circuits and equipment before working on them whenever possible. Use lockout-tagout procedures to prevent accidental energization. Maintain a safe working distance from exposed live parts. Use insulated tools and equipment. Never work in wet or damp conditions. Be aware of your surroundings and potential hazards. Follow all safety procedures and regulations. If you are not sure how to do something safely, ask for help. Regular inspections of electrical systems can help identify potential hazards before they cause problems. Look for things like damaged wiring, loose connections, and overloaded circuits. Test ground fault circuit interrupters, or GFCIs, regularly to ensure they are working properly. GFCIs are designed to protect people from electrical shock. They should be tested monthly by pressing the test button. If the GFCI does not trip, it should be replaced. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical conditions that can cause fires. SIs should be tested periodically to ensure they are working properly. Surge protection devices can protect electronic equipment from damage caused by power surges. Power surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protection devices should be installed at the service entrance and at individual outlets to protect equipment from power surges. Electrical fires can be very dangerous. If an electrical fire occurs, do not use water to put it out. Water can conduct electricity and make the fire worse. Use a fire extinguisher that is rated for electrical fires. Call the fire department immediately. Education and training are crucial for maintaining competence in the electrical profession. Electricians should participate in continuing education courses to stay up to date in the latest codes and standards. They should also seek out opportunities to learn new skills and technologies. Mentorship is also important. Experienced electricians can share their knowledge and skills with newer electricians, helping them to develop the necessary competence to perform their job safely and effectively. The electrical industry is constantly evolving. New technologies and standards are constantly being developed. It is important for electricians to stay up to date on these changes in order to provide safe and reliable electrical services. Licensing boards play an important role in ensuring that electricians are qualified to perform their jobs. Licensing boards set the standards for electrical licensing and administer examinations. They also investigate complaints against electricians and take disciplinary action when necessary. The electrical profession is a respected and trusted profession. Electricians play a vital role in ensuring the safety and reliability of electrical systems. By maintaining high standards of professionalism and competence, electricians can continue to earn the trust of the public.